So if you accidentally eat a Shield Dapperling mushroom, you're going to notice this pleasantly nutty flavor right before it makes you, well, violently ill.
Yeah, it's definitely not a fun time. But the weirdest part is that to the bugs living in the forest, that exact same mushroom smells like a burning tire fire.
Welcome to your custom-tailored deep dive. Today, our mission is to uncover the highly deceptive, mathematically precise, and honestly chemically ruthless nature of what looks like just a common woodland mushroom. So, okay, let's unpack this. If you were just walking through the woods and looked down at the leaf litter, the Shield Dapperling or Lepiota clypeolaria, it has this really quaint physical facade.
Right, it's got a shaggy, almost like booted stem and a small shield-like cap.
Yeah, exactly. I mean, it looks completely passive, just sitting there in the dirt.
But the mechanics hiding under that shield cap are incredible. Starting with how it reproduces. If you actually look at its spores under a microscope, they aren't simple, round little seeds. They're fusiform.
Fusiform, meaning what exactly?
It basically means they are shaped like tiny penguins.
Wait, penguin-shaped. That seems like a really odd shape for a spore, right?
It does, yeah, until you look at the physics of it.
Yeah.
That highly specific tapered design actually minimizes aerodynamic drag. It allows the spores to just slice right through the thick, stagnant air trapped beneath the mushroom cap.
Oh.
And here's the kicker. They don't just launch one by one. Thousands of these spores eject synchronously to create what fluid dynamicists call a cooperatively generated wind.
Wait, so they are teaming up to move the air. That is exactly like a microscopic peloton of cyclists.
A pelta.
Yeah, you know how cyclists ride in a tight synchronized pack so the riders in front break the wind resistance? It creates this aerodynamic draft that just pulls the rest of the pack along.
Oh, right. That is a perfect way to picture it. I mean, a single spore doesn't have the mass to carry itself very far.
Right.
But by launching thousands at the exact same millisecond, they literally drag the surrounding air with them. They essentially engineer their own microclimate to physically punch through the dead air and escape the leaf litter.
That's wild. So the mushroom goes through all this aerodynamic effort to launch its spores into a completely new patch of soil. But once it lands, it has to actually defend that new territory from rival fungi, right?
Exactly, and that's where the physics ends and the chemical warfare begins. What's fascinating here is that modern science has uncovered a massive paradox with this species. Its closest fungal relatives are notoriously packed with amatoxins.
Those are the deadly compounds found in things like the death cap mushroom, right? The ones that cause fatal liver failure.
Yes, exactly.
So if it's dominating rival fungi so aggressively in the soil, I would just assume it's packed with those same amatoxins to kill off the competition. Is that what's happening here?
Well, that's what scientists assume too, but recent tests using liquid chromatography mass spectrometry.
Which is a mouthful.
It is, yeah, but it essentially acts like a microscopic sorting machine that weighs and categorizes every single molecule. And it proved that the Shield Dapperling contains absolutely zero deadly amatoxins or phallotoxins. None.
Wait, really? Zero.
Zero. Yet, it acts as a ruthless biopesticide in the soil. It shows 100% inhibition against pathogens like cytosporic racosperma.
Hang on. If it doesn't have the lethal amatoxins, how is it achieving 100% inhibition?
It doesn't just block them. It actively secretes alternative compounds that literally break down the cellular walls of encroaching fungi.
Whoa.
Yeah, it dissolves their structure and completely starves them out of the soil patch, all without relying on the classic lethal toxins of its family.
Okay, but if it's missing the deadly amatoxins, why do foraging guides still label it as strictly poisonous for humans?
Because it still packs a severe gastrointestinal punch. I mean, it won't shut down your liver, but it will make you incredibly ill. Which leads us back to that baffling sensory contradiction for anyone unlucky enough to forage it.
Right. Here's where it gets really interesting. We mentioned earlier that this mushroom smells absolutely revolting.
Yeah, like burnt rubber or rotting garbage.
Exactly. But victims who have accidentally eaten it report that it tastes deceptively, pleasantly nutty. I mean, why on earth would a mushroom smell like a tire fire but taste like a gourmet snack?
This raises an important question regarding evolutionary defense, that burnt rubber smell. It comes from volatile fatty acids acting as a targeted chemical weapon.
A weapon.
Yeah, it functions like a chemical do not cross tape. It signals specifically to insects that the environment is highly toxic for their eggs, keeping them away.
Oh, I see.
But human noses and taste buds, we process those chemicals completely differently. So the pleasant taste becomes this dangerous, deceptive trap for mammalian foragers who just ignore the warning smell.
Man, that is intense. So what does this all mean? Well, for you listening, it means the next time you walk through a forest, remember that the unassuming leaf litter under your boots isn't just a quiet living room. It is a high-tech battleground of fluid dynamics and targeted chemical warfare.
It really is. And if we connect this to the bigger picture, consider this. If this tiny, shaggy mushroom can chemically dominate its soil patch, dissolving rival fungi and deterring insects without relying on deadly amatoxins, what other revolutionary, untapped agricultural medicines are quietly fighting turf wars right beneath your feet?